Hey, quickly checking echo. If you're getting echo, please tell me. If you're getting any echo, please let me know. I don't think you should get echo, but I'm just checking. Echo. No echo? Good. Yeah. Okay, I am making sure that we don't get any echo, and so I switched over to this headset, which will basically ensure that you don't receive any echo. I was suspecting echo the last time also, and nobody actually complained. Maybe I was the only one receiving echo. Or hearing or perceiving that you may be receiving echo. But if there is no problem, there is nothing to solve. So why bother? Okay, let's see who's here. We have a few people, 3 people. Okay, Brian, John, Chris. Hello, guys. We missed a couple of you. We tried to meet yesterday. We got together, 3 of us. That's it. So it was a short, small group. I guess last minute cancellations happened and many of you could not join. So we'll do it again sometime. Let's see. Okay, somebody is dealing with his professional microphone setup, it sounds like.
No, why? I toasted a sandwich. Yep.
Okay, so I think we should get started. So I'm beginning to share my screen. And what I will do now is make sure that we are able to focus on the ideas that I want to discuss today, which is basically reaching the point where we can run our own platform as a service. And that requires us to behave like a developer to begin with, and then extend that idea of creating a sample application, loading up on an existing platform as a service from a commercial provider, and then figuring out how do we run our own service, our own platform. That's our end game in this cloud technologies segment. So I will begin describing what I'm talking about today in some of the steps that we will have to go through, and then jump to the point where we can actually set up our own. So today is day number 6. Is that right? Let's just confirm that. I don't want to make a mistake, and so I will open my calendar and confirm that today is the day number 6 in the sequence. And I'm just confirming that piece right now. One, 2, 3, 4, 5 sessions have happened. So today is the 6th day. Okay, good to know. And back in this OneNote notebook, what we intend to do today is, like I mentioned earlier, we have to become a developer, or at least pretend to be one. And the idea of a developer would be that you have some kind of an application that they will build, and they will put that application in some kind of a package. And this package needs to have a systematic method of source control. And so we intend to use one technology that is immensely popular. That technology is called Git. We will use that, first of all, understand it, and then take a sample application, build a sample application if you like. And then once we have a sample, in our next iteration, what we intend to do is take, first of all, say build a sample app, and then package it up and push where we send it to some platform as a service. And we intend to use this company, Heroku, as an example, Heroku.com. They are a well-known platform solution. And so that's the getting your hands dirty with the process of building an app and packaging it up in a Git repository, and then pushing it to a platform solution that will go live. And that's what we will experience. That's an easy exercise that's there. We have an exercise for that, by the way. And then we will switch our roles. Then we will switch the role of a platform developer. our role will then become platform dev, in which case our customer is going to be a developer. And so they will pay us money, we give them service, and what service we offer them is going to be a platform as a service. And this is an academic exercise, so there is no money transaction, but we'll just pretend that somebody is a developer and he or she is going to give us money and we give them service. That's the scenario we'll play. And so we'll have to construct our own platform. The construction of our own platform is what we intend to do. We intend to use this application called Days. It is on GitHub. We will use that and install it, set it up, make the platform as a service go live. And then once it goes live, then we'll switch again and become a developer. And then do the same thing again, get our package, push, and then that's it. It goes live. So take the package and push it to our own platform as a service. And it goes live and we can see it and be happy. And so that's the plan of action that we intend to go through. Now, while going through, we need to understand this idea of Git. So that is what we begin with right now. And so I am preparing a new page. And in this page, I am basically going to talk about Git. So Git is a source code control system. Let's call it, am I on the right page? Yes. Source code control. That's essentially what it does. And so think about this idea that I'm going to talk about and describe is the idea of what is known as a directed graph. Now, this is familiar to people who have math background, but if you don't have a math background, don't get scared about this name, directed graph. A directed graph is basically like, think of it like this idea. I'm going to, there's a chat request. What is the chat saying? I don't see a chat. Maybe I saw something that is not there. Oh, so Sandeep just typed his name. Okay, got it. And so what I am going to do now is give you this idea of what exactly a directed graph will look like for those of you who do not know what directed graph is from math background. So if you know what this game is, Tinker Toys. And so if you look at this game, for example, you have seen this, probably have played it also. If you're from this country, you probably have played this game when you were young. And so this game, if you think about it, and you look at this picture carefully, what the person who's playing that game will do is basically put together these lines, like the red line here and the green line here. Those are those red and green and yellow lines are connecting things together. And the things that are being connected are these round objects, sometimes square objects, sometimes cubical objects. So variety of objects, you put things together. And these points at which these wooden elements are clubbed together, we will call them nodes. So I'll describe what I'm talking about. So a directed graph is more like a Tinker toy. So Tinker toy. Think like that, at least. It will help you understand what's going on. And so now begin discussing this idea of Tinker toy or a directed graph is where we will put stuff in a node. So this is going to be a node. And then we will have another node. And then we will have a way to go up this way and come back that way if you like to. And that's the kind of traversal we can do, go up, go down from node this to node that. And that's the kind of sort of idea behind a directed graph. You have a state of something in every node. So every node represents a state of something. So this node has a different state from this, the two different states, two different nodes. It's a state of something. Now, in the context of source code control, the idea would be that you have the state of the code that you want to put code in there, right? So we'll put some code in. Where do we put a code? Any code we can put in a folder or a directory, whatever you call. It's basically a place to store stuff. You create a folder or create a directory, and that's where code will live. So effectively, if you have a terminal and you open up to create a folder, let's call it mkdir, I'll call it my Cloud Genius folder, and I created it. And this folder contains nothing. And that is expected. I open it up in Atom Editor and I see that it contains nothing. And that is totally expected. It's an empty folder, I just created it. But that is my intended place. So this place is what I intend to store my stuff in that folder. That's my intention. And so I'm expressing that my current code that I will create is going to be sitting in that folder. That's my idea. So everything about my code is going to be stored in that folder. Now, when I have that folder, I can add files, I can delete files, I can change files, I can move them around. And when I do these actions, these are actions. And so when I do this thing in a set of files or maybe more things like create a folder, subfolder, create subfolder, whatever action I am doing, that basically materially changes. It's a change happens to the folder inside it. You will see those changes reflect in this Atom window. In the folder Cloud Genius, you will see that it creates something. For example, if I go here and say create a file, I'll call it a file called ABC, and that file gets created. I can go and see it in the Atom editor. It's right there. Here is the file. The file is empty, so I just modified the state of my folder. So effectively, we can use this idea of storing stuff in a folder pretty much like we do every day, like every single day, except the usage of Git used to be originally limited primarily to storing and managing code. That doesn't need to be like that anymore. In fact, people store anything you want, and Git can handle it. It can handle any kind of file that you want to put in that folder, and Git will be able to manage change. Whatever changes you make, Git can manage it. It doesn't need to be just code. It can be any file. You can put that file in that location that you designate. So this is my designated location. I call it Cloud Genius. And in that folder, I will put anything I want and I change it. As I change it, I want to keep track of this. So that's the whole idea. The beginning idea that I was talking about is to be able to control my source code. And so I want to be able to control the state of this folder. A state of folder will change all the time. And these changes that I'll keep making, add a file, delete a file, modify a file, save this, save that, move it here, create a directory, create subfolder. All of these things are changes. But at some point, I will kind of settle down and say, you know what, now it looks good. So I will then mark it so. This looks like a good milestone. So when I am kind of sort of happy with the changes I just made, at least for the time being, I call it a milestone. And so that milestone is what you should think of as a node. When I get happy about something that I made changes about, and I want to give it some kind of a commitment. And so the idea would be that you actually make a commit. And so there is a command for that in Git called git commit. And when you do this command, it sets a milestone, creates, and marks a state. This state definition is marked in form of a SHA-1 hash. So a SHA hash is created associated with the git commit that you create, and it becomes a node in your Tinker toy. So this picture that I attempted to draw but the good looking picture is right here. So what I'm going to do is actually refer you to a video, Git for 4 years old. That is the video. It's coming up. It's a very good video, and it is exactly meant for people who are 4 and higher. And I will be taking that link and giving it to you. So that link is coming in your Slack chat. You should watch it later. Don't have to watch it right away. And that is the link I would like you to watch. It is, if you're 4 years and younger, you should not watch it because it's not meant for you. That was a joke. And so next one. Oh, thank you. Thank you for laughing. Okay.
We were discussing yesterday during the dinner how one of the disadvantages to having an online class is that since everyone's on mute for the most part, you can't hear if your jokes are actually funny or not. So Nilesh is there wondering if he's telling funny jokes or if they're total duds.
Most of them are duds, but
I disagree.
sometimes it's amusing, lightly amusing. So thank you. The idea that I am describing essentially is we are going to manage our state, our milestones, our idea in our head, because we keep changing stuff, and that's how life is. Like we change something. I like this, I don't like this, I modify, and I then feel good about it. When I feel good, I make a commit. When I commit, I create what looks like, and let me draw another lame picture. So I begin with nothing, and then I add stuff, I modify stuff, I delete stuff, and do stuff, and then I feel happy about it. So when I feel happy, then I say, you know what, commit. So then a new Tinker toy gets created. So I should erase this illustration a little bit, and when I feel happy, then I create a Tinker toy like that. And so this Tinker toy gets assigned a SHA-1 hash. That's my node, my first. And then I want to improve what I just did. So then I begin again from this point onwards. And so I begin, and then I keep changing, and I keep modifying, deleting, destroying, creating, adding, copying, pasting, whatever. And then I feel happy again. And when I feel happy, I create another commit. And then I get another SHA-1 hash. The SHA-1 hash basically is a reference. It's like a name for that node. And I can then, for that node, I get a name in form of a hash, and I can then traverse here or there comfortably. And when I do travel, I go from A to B, X to Y, SHA-1 to SHA-1, one SHA-1 to another SHA-1. Then I see that my folder actually changes the state, and it reflects the state of my mind at that time. And or if I go to that location, it reflects my state of my mind in that time. And I can just modify this thing very comfortably. Let's go see a live demo. So here I have this file, which is ABC, and it contains sorry. It basically is empty, right? There's this file empty. So I have this, this contains almost nothing. And I save it and I close it. And then back in my folder, I have this file which contains something like this file, contains some 30 characters. And I am going to now begin marking this folder as my repository where I will store anything I want to store. I just stored a file called ABC, which contains almost nothing. And in that file, I want to be able to preserve its state. I want to call it a commit. So before I can commit, I need to tell this folder that I want to treat you like a Git repository. So the idea would be to initialize Git. Now Git is already installed on the machine, on your workstation, as well as this machine. And so I'm going to just use that Git init. And I want to initialize Git right here in that folder. Which folder? This. The dot indicates this. So I initialize, and you see that something happened. It said I initialized a empty Git repository in that folder. So that folder got created. Let's go see what happened here. There is a new folder got created, which is called .git. And the .git contains lots of things, tons and tons of things that I don't need to worry about because that's what Git handles. So I'm basically going to be ignoring that folder, .git. It is supposed to be a hidden folder because of the fact that it has a dot before the name, .git. Anything with a dot is a hidden folder. You don't actually see it in a listing. You see that I don't see it. But if you list all the items, it will be seen. So like this Git showed up because I am using the -a option. But that Git folder is .git folder is where Git stores its own information. Right now, it is empty. So Git doesn't know that there is a file called ABC. So I need to basically tell that I am happy with what I have and I want to make a commit. But to do a commit, it's a double-step process. The idea is you have to first put whatever you have in a staging area and then say, okay, commit. That's the step, 2 steps. So if you want to commit, the idea is before you commit, you want to put items on a stage and then you commit. That's a 2-step process in Git. That's how it is designed. And so the staging requires a command called add to the stage, and commit is a command called commit, add to stage. This to stage is implied. This is implied. And so these are subcommands. So there is a git add command and a git commit command. Those 2 commands will basically help us put it on stage and then make a commit on the next step. So let me just do this quickly. So I will go back here, git add, and I'll say git add my ABC file. So it adds. And then I say git commit whatever I have, and so I enter. And it says, okay, I want to commit, but I want to know what your idea is. So you please describe your idea. So here is my idea behind this commit. I just described something. I am adding a random file ABC containing almost nothing. And this is my change. So it's my change notes, whatever I change in my changes. And I just write that line out in an editor. So this is the information that goes along with the commit. It will help me understand what changes I'm making. What did this folder contain? Now, after I save this, so I will have to go Control X and enter yes and enter and save. So it saves. You can see that something happened. Git commit says, yeah, there's a commit created, 1 file changed, 1 inserted, and that's what you see currently. Now, if you look at the listing, you still don't have anything right here. It's just the file ABC we created. If you list the whole thing, you will see that there is .git folder, and it basically does, store information about what Git did. So now, if you want to see this visually, there is a piece of software that you can download on your Windows or Mac that shows you visually the Tinker Toy I was talking about. And so that software is here. So it's going to open up and show us the Tinker Toy, the beginning point, just the beginning point. And so let's see if you can go and see the Tinker Toy right there. That dot that popped up, you can see it more clearly like this. And here is the graph being built with this one Tinker Toy. And the description is whatever I wrote down. And that's the initial Tinker Toy idea, which basically stores the file called ABC. And in this green colored ABC label indicates that it is an addition. I added this file called ABC in there. So you can see hold on, let me adjust the screen. Okay, there we go. And move away, please. Move the video. Okay, hide away the video. Why would the video not move? Okay, moved. Oh, there we go. So this file called ABC, it contains almost nothing right there. And the label is right at the top here. So that's the first Tinker Toy I just created. Now, the beauty of Git is that you can completely delete that file, ABC file you have here. You can sorry, this file I have ABC, I can get rid of it, RM ABC. It goes away. And I have not, that file is missing now. I can make a change. So this is considered a change. I deleted something. But that doesn't mean that I lost data, even if I actually remove the file. You will see in my Git repository that the file is missing. My ABC is gone. But since I said that we are preserving the state of the commit, sorry, not this commit yet, not this commit yet, but the first one. I just made a commit and I added a file ABC, and then I successfully committed. I got a SHA-1 hash. You can see the SHA-1 here, actually. Git log will show you. This is the SHA-1 commit right there. This SHA hash is available. And so this idea is that this state of that folder at the time it was created is preserved. I just deleted my file after that. However, I can go back to it. I can go back to the state it was by just resetting the Git to that point of commit. This means I can check out Git checkout, and then give me that SHA. So I can say, give me this 4448 SHA. So I can say, give me that SHA, and I got it. It looks like I have that file back in place. No, I still have to reset. So just Git reset, and then hard reset brings the file back. So that file ABC is now back in place, just like the way it was, which is in your notepad. You can see it in Atom. That file with its content is back in business. Now we can make some changes to it. We can make some changes like this, save it, close it, back to the visual editor. You can see that this editor actually shows you something changed. And these are uncommitted changes. You can see them here, uncommitted changes. I can zoom it a little bit to show you uncommitted changes that came up as another tinker toy that is uncommitted. And you can see the change itself. The change is being shown in here. And the file originally had this contains almost nothing. Now the file has this random string that I typed. It is a green item, which is meaning that I intend to add that line, which is not exactly what I want to do, but that's what it shows. Now, if I like this change like this, I can keep it. But I can maybe this doesn't make sense. So I delete it. So I save it, and that changes get disappear from here. It will immediately go away because that's not what I intend to randomly type something random. Instead, I will modify this to have some meaning. For example, this contains something. So I made that change now, and I close it. I made a change in an existing line. You can see that the change is represented visually right here in form of a difference. The difference shows up like this. So the red line is deleted. The green line took its place. I have a question about this zoom thing. When I zoom, do you actually see it zooming, or just I see it zooming? When I zoom, like this, like this, do you see it zooming, or do you not?
Don't see it.
I don't see it.
You don't see it zooming, huh? Only I see it like zoomed up. Interesting. So I should not use it then. It doesn't transmit through this Zoom software, which is the name is Zoom. It should actually show the zoom, but it doesn't zoom. Whatever. And so I will not zoom now. So the idea behind this change that I just made is this that I want to. So different repository. Close it out. Back here. Yeah, this change that I am making, the red line and the green line indicates the change. The red is the one deleted, and green is the one that is being added in place on that line number 1. And so that's the delta I make. Now, if I'm happy with the delta, I could accept it. And for accepting delta, I need to go and git add that file one more time. It's a different file, different content. I add it. And now I say git, please commit. And then I need to pass that message about what did I change. I can go just type enter and then use a full-fledged editor to type out my message. Or I can just say, you know what, I would like you to, pass this message right here in the body. So I could go like this -m option and then give it a string, something like I changed something. And then I enter. And so it adds that new tinker toy. So let's go see git log, and you can see that the two tinker toys now. See them. First one is the one at this timestamp. And you see that the first commit with this commit hash, and that's the original random file containing almost nothing. Then I change something, and I say that I changed something, and the file now contains the changed file. You can see that in Atom Editor right here. The file is containing something. So now we have two tinker toys, the first hash and the second hash. You can see them in the log here. This is the second hash right here. And the first hash is this one. So we now have, pictorially speaking, two hashes, two tinker toys, like this one, like I erased out. Let me bring them back. So we now have the two tinker toys, the one here and another one here. These are two nodes, and they indicate two times when I was happy about what I did. And so I make a timestamp and a commit and a SHA corresponding to it. And that's how I'm preserving all the changes I'm making. Now, this is a very simple way of starting to keep track of what was it before and what is it now, and how I want it to be going forward. And that's good for a one-person operation. I'm operating on some folder, creating something, deleting something, adding, destroying, moving, this and that, building my application basically. And in the process, I'm keeping track of what was it before and what it is now, and so I can very meticulously craft whatever I want to. That's the primary idea. But it's not limited to just that. We can collaborate across a team of people, like all of us together. And I want to do that exercise right now. So what I want to do is, for our team.
Hey, Nilesh.
Yes.
Just a couple questions before you get into that.
Uh-huh.
So what would have happened in this example when you deleted that ABC file initially?
Mm-hmm.
If you had committed after deleting that file, would it have reflected in the repository as a new node with nothing?
Yeah. Correct. Yes. We'll do it right now. So here we go. We will have that file that we have. We'll delete the file, and now it's gone. I will say git status. We'll see that the file is deleted. Right.
Okay.
Here.
Mm-hmm.
Now this is a different state. Right. Completely different state. So I can say git add. Everything I have, it adds, and say I git commit, and then I say I deleted ABC, and then I commit. So now my folder contains nothing, and my git log says three things: my almost nothing file, there is something file, and a deleted file, and my listing contains nothing. Right? Now I can go back to any point in time by traversing to that git checkout, like git checkout. And which one you want? This one. I want to check that out. Git checkout. Boom. And I see that I have nothing. So I say git log, and I can say this checkout, please, this time. So git checkout, and this one. And I see that file is there, and I can cat it and ABC. It shows me something like that. And I say git checkout, the very first one actually, which is this one, copy checkout. And I see that my git status shows me where I am, and then the listing shows me the file, and if I cat it, I see it. Almost nothing, the very first file. Right?
Okay.
You can traverse. Git log lets you see the tree. You can see that in visual form. This shows up in form of your, hold on, master. Let me just check out the master branch, and I'll describe this also. So git check out master to show you visually. And now we'll go back to here and see the three tinker toys that I wanted to see. Oh, I need to be all the way on the top to see that. And so git log, and I am on this point, right? Hold on. Hold on, where is that topmost log I wanted to get, which is this one. So I'm going to go to that, git check out that one. And now I should see git log with 3 entries. And that is this one, 2, and 3. And now visually speaking, I should see that in here. And
okay.
1, 2, 3, all three things show up in form of a simple tinker toy with 3 dots and two connecting lines.
Okay.
And
so this repository is stored in your GitHub account online, right?
No GitHub yet at all. It is
so
totally,
we haven't gotten into GitHub yet. Okay.
No, we didn't go to GitHub. It is stored in this folder right there. That's it. There is nothing else. It's completely included in that folder, which is called Cloud Genius, and that's it.
So everything we've done is completely offline so far. Okay,
completely
cool.
Local, nothing connected to the internet, not even anything outside this folder. It's in that folder, which currently contains nothing. It is empty.
Mm-hmm.
I can check out something I want. Maybe I want to get this checkout, so the second hash. So I can check that out. So as soon as I check it out, double click, And so say, okay, this is like visual checking it out. And now I can see that the folder contains ABC.
I see.
And now I can go back to my head and play around with the tree that I have and basically mess around if I like to. Now what you will see that if I go back to my terminal, okay, so back to the terminal. If I now decide that this folder that I have called .git, this folder, by the way, this is a piece of trash that Macintosh creates, and we don't want to use it. We should get rid of it like this. Like this. You could get rid of it because I don't want to store that stuff, so I can get rid of it like that. However, there is no need to. What you can do instead is that, because this is a piece of clutter, I don't want it in my repository. So I can technically delete it if I like, or just decide to ignore it. Yeah, it's there, but I will ignore you. I would like Git to ignore you. There's a concept of ignore. So what we intend to do now is to go here in that folder and create a new file. And in that new file, what I want to do is create a new file and save it as a file called .ignore. That's the name I want to use. There's a specific name for that, .git ignore. That's the name it needs to be. If I do that, then this Macintosh doesn't like, so I'll say I use dot, and that's great. So I have a new file called .git ignore. And what I want to do is ignore the ds_store crap that Macintosh creates. And so I will say .ds_store. This file should be ignored. So I just define a pattern that I want to ignore, and I can just save the pattern. This is just one file, so I save its name and save it and close it. So now you will see back in our Git repository, Git status, that there is a new file called .git ignore. Good. But you will see that the ds store file is not visible at all to Git. Git cannot see it. Listing can. Listing can see it, but Git cannot see it. And the reason it cannot see is because you ignored it. Now you modify the ignore file, go back here and go in the git ignore and remove this entry and save. And then come back to git status. You will see that there is a, hold on, why is ds store not showing? cat.gitignore. Maybe I have a global git ignore somewhere in my computer. It should show. This file should show as a new entry in the git log. I think I have to go check my Macintosh might have globally ignored that piece of trash, this piece of trash. So we'll create another trash. So let's say touch a piece of trash and now say git log. And now you can see that, git status. And now you should see that there is this trash created and git ignore created. So now I can, if I want to ignore this trash, I could by just modifying this file git ignore and adding a line called trash like this. So in the git ignore file, I'll say ignore trash and save it, close it, and back here and check git status. You can see that the file trash is ignored. Now, if you move the file or rename trash to something called dirt, then git status, then dirt is not ignored, trash is ignored because git ignore ignores it. Trash. It doesn't ignore dirt. And so that's the idea of ignoring. It basically makes Git ignore certain things on a pattern you define in the file called .git ignore. Now, having discussed this briefly, there are lots and lots of things to do with Git, and I can keep on going. It's, for hours, but that's not the point. Our point is to be able to understand how we use Git in a collaborative fashion to not necessarily become a developer, but instead use this information as a collaboration tool, as a tool to help us accomplish what we want to do in our work, whatever that work is. It doesn't need to be a development work. Just because this tool is so beautiful, it allows us to manage very carefully and in a structured fashion, keep track of changes that we make on a team basis, without having to depend on or stomp on each other's feet. For example, there are other types of source code control systems that require everybody to go in a central location and be dependent on other people to finish their work before they can even start. And that's a problem in those systems that require a central checkpoint. This thing, Git, doesn't require it. If you look at the Git software here, Git SCM, the definition is that it is a free, open source, distributed version control. It doesn't have to have a central point. Now, GitHub is a service. It's a software as a service that uses Git as the software. GitHub is not Git. GitHub is a commercial company. It's a good commercial company. And the Git is an open source software created by this guy that you probably know. This gentleman created Git in 5 days, practically. And he also is the creator of Linux, the kernel, and whatever you use, most of the time I use. So this gentleman created Git to store and manage Linux kernel. And now it is being used for storing Windows also. So a bunch of other people, and almost every company I know of actually uses Git to manage their software operations, if you think of it that way. Not necessarily just the development, but software operations. And that is phenomenal in terms of what it can do. And it is distributed, so it doesn't lock people up. That's the primary benefit. And so we will play that scenario right now by using a method of collaboration without getting too much nerdy about using command line. Just do it visually first. So we'll go to GitHub, log in. And there, what I want to be able to do is whatever repository I have here, this repository that I have, I want to just clean up. I'll remove the dirt and keep the git ignore. And so let's go see in Atom, what do we have? Git ignore contains .ds_store. And then I can keep this something, and ds_store can be whatever it has. I don't care. And then in that folder, I will add everything. So git add everything I have, and git commit is this file, which is going to be ABC. But before I make that commit, I want to make another change. So I'm still not made up my mind. What I want to do is, this is going to be a project file. So this is going to be I'm going to rename it. I'll call it the readme file. I just renamed that file to readme.md. And here I'm describing the project. Hello team, let us together create 26 files, each with a file name representing the letters of the English alphabet. So simple project that I am assigning as a team leader to all of us. And then that's our goal. So our goal is to create a folder, this folder, whatever we have. And in here, I would like us to create individual files that represent letters of the English alphabet. Something like, I'll give an example. For example, I have created the file named A. That's it. So here's a file called A, and I save it as A, and there it is. So now we have a file called A created, and that's what I would like us to do. Now 25 files need to be created together in a team setting, and this is the repository that we created that contains a readme file, a ds_store, which will not propagate, it will be ignored. There is a git ignore file, which is what it indicates what needs to be ignored, and there is a file called A, and a readme file to read. So that's the exercise for the team that we will do right now. And so we'll save this, close it, and back to terminal, look at our git status. In the status, we see that this file ABC was deleted, which is correct. It was created in this name, so we renamed it. We have this file A created, and a new file called git ignore is existing. We have to add all these changes. So git add, and then commit. And with a message, here is a project for the team. So this is the project I created. Now I can see git log, and I see that all the latest. So here is a project for the team is the latest log I have. And what I want to do now is send this in a fashion so I can give it to you guys. Now you cannot connect to my computer directly, so I need to go use a third-party service, which is going to be this. So I'll go to the Cloud Genius page, and in here, I will open a new placeholder. That's the placeholder. And I'll give it a name, alpha. And that's the name. I want to make it a public repository so all of you can just comfortably access, and then create this placeholder. The name repository here right now is actually somewhat ambiguous because there is no repository on the website github.com. It is just a placeholder. The repository actually sits right here in that folder. This is where the repository is. There is a file called readme, and there's a file called A, and it looks like this. That is the repository. No, not this, not this. Looks like this. And this is the repository. That looks like with the readme file and all that. What GitHub is indicating that create a new repository is actually technically wrong. It is a placeholder for a repository. When you are actually saying create a repository, you're not really creating anything. You're just creating a place. So we create that place. And we did. Now it tells me, do you have an existing repository? Yes, we do. So that's the segment we'll do. We have to push an existing repository that we have. We'll push my content from my folder into the service. And so the steps are here to run this command and then another one. So 2 commands, we'll do one at a time here. We will say, you know what, boom. And then another one. I'll help you understand what these means, what these things mean. So the next command I just did here. Let's go read that. Git, please add a remote. Add a remote called origin that is located at this location. That's what this command does. So what we are essentially doing is in a picture illustration, we have this repository that we are dealing with. Like we have 1, 2, and a bunch of other things and more Tinker toys. And so, excuse me. This is what I have currently, a bunch of these. I don't know how many, I lost count. But this is a repository that I have in my folder. And what I'm saying is, hey, Git, I would like you to add a remote. And the remote should be called origin. That's the name of the remote, and the location is this HTTP URL. Sometimes it is SSH URL. You can choose the URL type and all that. But that's the origin is the name I choose, and it's going to be a remote brother sister. So it's a sibling that you will have somewhere else. I want you to add that remote. So just it adds that remote. So we'll do that. We'll see in here we added a remote. Let's go see Git, show me your remotes. Git remote -b. That should show us the remote connections. So it shows the remote connections as the name origin, and the actual location is this. And it is for fetch as well as for push. Both actions has the same name origin for the same location as well. That's the remote we established. Now, what we need to do is, in the picture, we'll say now that you know this remote called origin, which is located in GitHub, I would like you to push. Send whatever you have here over to this remote, which is called origin. The actual location happens to be on GitHub. So push everything you have. And it will know where to go push because we have a placeholder. So the placeholder is this one. So the last action is git push. Git push what? Git push -u origin, meaning, to this location, I want you to push to origin. What do you want to push? Whatever you have in your master branch. So we just have one branch. So it's going to push everything I have here from here over to GitHub. It just finished pushing. And you will notice that it did not require any login authentication, which is kind of surprising. And that is because I'm using SSH on the back end. I don't have to type passwords because I don't like to type passwords because I find passwords are boring. And so, but honestly, you are not set up for passwordless authentication. So you will have to use a HTTP URL and you have to type a password because you're not set up yet. So this HTTP URL type is what you will be using, not SSH URLs. And that is what you will see in this location that I have successfully pushed, which means if I refresh the page, I should see my code right there. Now here, what I see is, hold on, I did not push the README file, it seems. Maybe I think I'll just clean it up to avoid confusion, because there is a potential confusion I can see coming up. What I will do is delete and just do it again quickly. So I'll delete the whole placeholder repository right there. It is called alpha. So I'll just delete the whole thing, completely gone. And back here, I will also discard all Git elements completely from here in the folder. All the Git things are gone. They will be gone pretty soon. So here I have this Git repository, but I want to make sure that all the Git related items from here go away. I can do that simply by deleting the rm.git folder. When that folder goes away, my Git status shows it is not a Git repository. So completely all the things about Git are gone. Currently, I have these files. I will also clean up the .ds store, and now it is somewhat clean. Now it's still not a Git repository. So now we are beginning from scratch again all over. Simply speaking, I'm doing initializing a Git repository here. Then I add everything I have in the folder, and I'll say git commit. Please take this and give it a commit message. The message is, this is a project for the team, and commit it. Now this Git status shows me that there is one Tinkertoy. That's it, one Tinkertoy. Git log shows me one Tinkertoy, because all the older commits I have erased, deleted my Git representation completely, and I have only one thing, which is this. Now I'll go back to GitHub, and there I create a new repository, which is a placeholder. I'll call it alpha, and then make it public and say, make a placeholder, and then push. But before I push, I need to set a remote. That's my remote connection. I established my remote connection. Right now, there is no remote. Git remote -v shows nothing. Then I add a remote. Then I see my Git remote shows me two things. Sorry, not remove, but remote. And I see two things, fetch and push. So now that I have remote established, I need to push my content. I can push simply by going like here. So I push my changes, and now my repository over there on GitHub should show me whatever I have here. Let's go see if it does. Refresh, and I see that there is a file called README, and here's a message for the team. So hello team, let's do this project. So how do we do that collaboratively together? So that's what I would like to describe. In the simplest fashion that you can use Git is just using the web browser. And you need to know what you're dealing with. So here is the project link. So I'll send that link over to you in a Slack chat. And here it is. And now, in that link that you have, you should be able to log into your GitHub page, and you should be able to see this particular location. Now, what you need to do is basically create a file called B or C or D and E, like that, all the way through Z, all the 26 files we need to have. For example, I have created only one file called A. And so what we want to do is just create a new file like this, create a new file, and name it B. We don't need to have anything in the body of the file. That body can be empty. And so we just create that new file. Now I have two commits. The moment you create a commit a new file, I got two files, A and B. And I can see that in my latest commit, I made a change. I added one file called B, and I can see this in a repository layer that I have A and B, and I just made a change here on the GitHub website. I can bring that back locally here simply by doing a git pull. I can pull it. So when I pull, I see that I have two files, A and B. So I just made a change here on the website, pulled it down. What I would like you to do is, somebody already forked it. Who is that? Okay, it's me. So I made a modification to it. And so that is me doing it. What I would like you to do is, please create files and add changes, make changes to it, and finish off the exercise, which is to create 26 files. Let's do it. In your browser, should take like half a minute and create a file and commit. You can see that you can create these edits and send me what is known as a pull request. The reason you have to go this way is what I would like to describe. When you will change, you will see slightly different behavior. The reason is that you don't yet have permissions to make edits. You cannot edit yet. You cannot edit the repository yet because I have not given you permissions yet. So I have this repository which I created, and I began with creating an A, then I made another change and created B. That's what you have. Now, when you begin to create a new file, you will see that it completely forks and creates exactly what you have here in your account. And then you get to create another with C. And that's the change you will make. So this is going to be the change that you will make in your fork. So in your fork, you're free to change, free to edit. And when you make a change like this, for example, the idea is that you have made a change. So you commit and you see your changes in your local repository on GitHub. But if you want to send that change back to the team, what you need to do is ask me to pull, request me to pull from here. And that is called a pull request, PR. So what I would like you to do is create a pull request asking me to pull your changes and incorporate into my repository, which is the team repository. We are going to use it or treat it like a team repository. So may I ask you to please create something like A, B, C, D, and all that, all the way through Z. Make a fork, which will automatically happen the moment you start to create something, and then change, and then send me a PR. Send me a pull request. Basically, it's a request for me to pull. That's what I'm expecting to see coming from you in the browser. And I see that there are no pull requests. There are 2 pull requests here. I see David added D. Okay. And there are 3 pull requests. Kalaivani added D also. Okay, there is a collision, but it's okay. And now we can see that capped. Who is capped? I forgot. Capped 10 is John, is it? Yes. So John is capped 10. So John created J, and there is no collision. So for me, it is easy. I can just accept that change request from Captain 10, John, and merge it. So I say, I create a merge. So I basically accepting the J change, and I pulled that request from John, and I want to thank John now. Thank you, John. Thank you, John, for J. And give that comment with a smiley and all that good stuff, and thank him for making a team contribution. And now in my repository, you can see that I have A, B, and J. I still have to go and make a decision on the other pull requests. So I see that I have this pull request called C from Sandeep, and I will deal with the D part, like there's a collision going here, right? So I'll deal with that later, but I want to deal with C. So let's see C. What happens if I take C? If I take the C, it tells me that there is no conflict with the base branch. So I'll just merge my pull request and say create confirm C, confirm the merge, and I'll tag Sandeep. So here we go. Thank you, Sandeep. And a smiley face, and boom. So I thank him. He contributed and all that good stuff. And so I can see that my repository now contains A, B, C, and J. Bingo. I'll go back to my terminal and say git pull. So it pulls. and it pulls and brings down C and J, and they're here with me now. I can see them visually in the local software, which is called Source Tree, and I'll give you a link for that. Source Tree is one software you could use here. Source Tree app. That's a good one. It is not open source, but it is free, as in $0. So that is free software. You can use this one if you like, or you can use the other one from GitHub, which is also free. GitHub Desktop is also free. It's personal preference. Both are good. You can choose whatever you like. It runs on both Windows and Mac. These are visual software you don't have to use, but nice to have here first time with Git. Now here you can visually see that the Tinker Toy building up very nicely in this segment specifically. The segment will show you that I began with this, and then I created B, and then somebody created, John created J, and then I merge. Then Sandeep created C, and then I merge. That's what we have currently in the visual representation. Let's go in GitHub and see what we got in GitHub. Close, and in the repository, we should be able to see the graph. Let's see what's going on. And there are people committing, like Sandeep and John has committed, and we have taken their merges. They've merged their pull requests. There are more pull requests coming here from Mr. Junaidi. Mr. Junaidi has created his first commit and testing on the web service. So this idea of a commit that he made is, this file called firstcommit.txt, and that is not according to our design. So let's go read the design. The design was that we need to create a file name representing letters of the English alphabet. And so this, for example, the file name is A. Whereas if you look at the pull request sent by our team member, Mr. Junaidi, you will find that his file name doesn't actually fit our specification. So what do we need to do? We need to go and talk to the team and say, hey, team, this doesn't actually meet our specification. The specification said it needs to represent the letters of the English alphabet. And the pull request that I'm looking at here does not. And so I'm sorry, but I cannot actually merge your pull request, so I will have to decline it. And so I will say, I'm sorry, I cannot, I cannot accept this pull request because it does not meet the spec. And I can comment, or rather, be nice and thank you. Thanks, Mr. Junaidi. Right, I like that acronym, the way you write it. I really like it. So thanks, DJU90. Sorry, I cannot accept this PR because it doesn't meet the spec, and comment. And it says you cannot comment at this time because probably Mr. Junaidi has removed his pull request, I suspect. Is that what just happened? No. So I will have to make a comment and then comment, and it went through. The comment went through. So I'm going to basically, ignore that pull request because it doesn't meet the spec. And so I'll go and decide on the other requests of the team. So we'll see create X. And so X looks reasonable. The file is X. I'll go see the file. The file is X, labeled correctly. The name is okay. And so I can go and accept that pull request. And I'll say, you know what, merge it, and merge confirmed. And then I'll say, thank you, Mr. J. John. Is that John, right? Yes. So thanks, John. There we go. And so, and make a comment for him, and he's happy, and I'm happy, and the team is happy, and we keep going like this. So basically, that's the idea. So we still have to decide between these two conflicting commits, Kalaimani and David. So we'll have to hold a team meeting. Hey, which one do you want to accept? Maybe there is a nuance that I don't understand readily, and so that I have to discuss basically on a meeting. That I can take the Z very easily. I take M here, but I cannot take these two. So I have to make that decision, and the way I can do that is to basically have a team meeting. hey, Karaibani, you sent us this D, which is nice, and thank you, and that looks meeting the specification. Good, thank you. What about the other gentleman here, who is David? So David also has sent us a file which is D, and it also meets the specification. But let's see, how do you break the lock? So basically, the breaking this deadlock, it's not really a deadlock, but it's mostly philosophical. You want to make sure that your team members are happy, and you get them together and decide which team members request that you will actually pull. And you either let the team members decide, or the best way is to let them figure it out. But if they cannot figure it out as to whose pull request should be merged, and these can be sometimes non-issues become issues for no reason. I'm just saying that it might happen. And if so happens, you can have a system of accepting, like I will use the first pull request I have if they are similar. So this is similar, and you can go by the first pull request, which was this one. So I'll take this PR and I'll decline the other one. This came first, so I'll take that. That's how you can decide. And so you can merge the pull request with, say, D, I confirm, and you thank both Kalaivani as well as David. And is the name Kalaivani correct here? Yeah, I will have to check that. And these are critical things. So the Kalaivani Cloud is the name. Okay, so let us say Cloud and David for the change, and I'm accepting one of them, so you understand that, and so nobody's upset about it. So thank both of them, comment, and you merge one of them and decline the other one, and you get the drift, right? You have to decline this, and you say, sorry, I already pulled, so it's a conflict. So basically, I have to resolve the conflict and saying I don't want to merge, and So D is for Dave. That's actually a bad merge because he wrote something in the file which is not according to specification. So we can again, go debating these things all the way, but I think you get the idea of collaboration. So the idea is to be able to have team members independently operate and create their content, create their changes, and send pull requests and merge completely independent from each other. And merges will happen as a team leader's perspective at his or her pace of operations. But typically these merges happen in a team meeting where team gets together on a periodic basis and they decide, what should we take, what should we not take, what are the implications, debate pros and cons, and fights. I mean, I've seen huge fights going on pull requests and mergers. It can be immensely challenging on big projects that has customer impact, and people will bring arms and ammunitions to fight, and so that that happens. But just saying that the best way to handle this is a person to person issue. Basically, it boils down to that. It's not a technical issue, it's a people issue, and you need to really be diligent about making sure that you're meeting the specification that you have, and then get everybody on the same page, make sure everybody understands, and agree, at least in principle. Or even if you don't agree, you make a note that I don't agree, but you move forward. And so this idea, which I'm just describing you, is the idea which is I call it disagree. Right, disagree and commit. Even if I don't agree, I still want to make a commit and move on. You can always come back and say, what, I told you it was wrong, I told you it was not a good idea, I said my disagreement right there. You can come back to it and make a change again, but don't get stuck. So this phrase, I think you should remember, is to disagree and commit and move forward, go ahead with something you collectively decide. You might fight tooth and nail. I say this, you say that, and we don't agree. You can agree to disagree and commit and move on. You can make that commit note in your Git log and keep it on record and on file, and you can always revert back saying, I told you that day. And you can win later. But right now, let the customer win. And that's how you should operate. So this is the crux of Git, is people. It is not the technology at all. It is how people collaborate to move forward, move a project forward. That, I think, what you should mostly remember is moving forward. And I think you get the idea of this Git thing. So we played with this setup of, we don't have to actually technically complete the entire A through Z exercise because it is, boring. But you could. I mean, I'm not preventing you from doing that, but I'm just saying that, it's lame. So I don't intend you to finish the exercise, by the way. So we can always see whatever we have done up until now and say git pull, the whole thing. And it pulls down and I can see the file structure. It shows up in my Atom. And I see that I have A, B, C, D, J, X, and some remaining pull requests and all that good stuff. But I don't need to. This is an academic exercise. Our idea is to make sure that we understand the flow and the purpose as to what we are doing, why are we doing, and how to actually do it. So I think we got that. So having done that part, let me pause here for questions on this Git business, because this is critical to understand how do we actually put this to use. What it does is gives us a way of going back and forth in any point of commit. We're going to go to that commit, go to this commit, go to traverse, go to a different branch. Like for example, here you can see the picture. There are these segmentations that like fork from here at this point. This yellow line goes away in a different direction. That's the John's direction, create J. And then that line comes back to the main. This is the main branch, the first line. And then you can see that this other green line forks out. And this green line goes here to create C. And this is Sandeep doing creation of C. And then his change also merges here. At that point, I merge it again. So things go separate ways and then they come back and go separate again and come back. And you can play like this and have the entire team in a large team. Let me see if I can show you a large repository as to how will it look like. Let's see if I have something locally. Yes. Is it a Git repository? Yes. So let's go open it up in Atom. So here you can see this is the Kubernetes source code repository, the master branch, and you will see a ton of stuff. Excuse me. What you're looking at in the Kubernetes example that I'm showing you are these lines and lines of people, thousands of people collaborating in creating the Kubernetes product. And this happens like every single day. There are hundreds of changes that people will send. And you can see that this picture, the colorful tree structure of Tinker Toys, is what variety of people are making changes to. And it can be daunting, but that is how modern modern software, not just open source, modern software is developed, is collaboratively developed independently from each other, and people get together in form of merges. So you change something, you send a request, it gets merged. And you can see in here somewhere, I have made a change and I send them and then they will accept. You can see that reference coming up in variety of source codes, open source mostly, where I contribute. And my contributions will be similar to what you just did. Like you send something and you push, or rather you send a pull request and the other person will pull. So Google guys who are managing this particular project called Kubernetes will be able to pull from whatever people send to them. You will see the people who are making contributions are this Mike and Kubernetes Summit Q and Everett and Kao and JUnit and bunch of people, Sham and like that. Lots of people make contributions. Some people from Red Hat company, some other from Red Hat, some from Google, some are independent people, some are like Gmail guy, the Fujitsu person. So lots of people making contributions. You can see them here in form of this gigantic tree, a gigantic Tinker Toy, and that goes on and on and on for hundreds and thousands of commits. That's what you see in the picture that I'm showing you. Our picture that we did was very, very small, very tiny. But a real project will be big, like I just showed you, Kubernetes. So let's go there. GitHub.
So Nilesh, another question.
Yes.
what happens when you pulled the repository back into your local machine?
Mhm.
What happened to the repository in your online GitHub account? Because I can see that still.
Yeah, when you pull it, it makes a local replica.
Okay, so pushing and pulling is more of a copy operation,
Yes.
not a move operation.
Yes. Yes.
Okay.
Yes.
So then how does it sync up in the future?
It doesn't.
It doesn't.
No, it doesn't. Nothing happens automatically in Git. You have to
Okay.
do, nothing happens automatic. You have to either push, pull, fetch, merge. All of these are mechanical operations because it requires human beings. You have to think, should I merge? You have to think, should I merge a conflict? How do I handle conflict? Is it a conflict or not? And
Yes.
yeah, so every action is a people action.
Okay, so I'm thinking of a scenario where, let's say, you pull this repository back into your local machine,
Uh-huh.
and you make some changes, but while you're making changes, there are other people online who have made changes, who have made pull requests to the repository online.
Yes.
How do you deal with those kinds of conflicts? Because now you're
So-
dealing with two completely different repositories.
Correct. So let's go play the scenario, and we'll play exactly what you just said.
Okay.
Here, in back in our folder or Cloud Genius, where the repository was, Git status shows me this, and Git log shows me this. So in the log, we have merging happen, and then merging happens, and then John sends a change X, and then merging happens, and then John sends another change. Sandeep sends a C here, and then I merge it, and like that. So these changes are happening, and I have a local copy, and I can git pull again if I like. But it's not going to get anything new until I decide to go and actually accept. So even if there is a pull request, that request has to be acted upon before. So I think here all the letters. So this guy Brian, he just dumped the whole thing for us in one shot. And so here,
Sorry, I was just trying it on not through the web service. I was trying to do it
I
through
understand.
command line. And
Beautiful.
experimenting. So.
Yeah, it's a good thing you did. And so what I think what Brian just did is brilliant. What he did is in one fell swoop, he finished off all the exercise that we wanted us to do. We wanted all of us together to do, and he has sent across a collection of all these A through Z that are missing. And if you just review the changes, and let's go see the files change, there are 21 items that were expected that are not there. So in one fell swoop, he has sent all the letters. That looks like a good change that I want to go and actually accept. So what Brian actually did is, back in our folder, he basically created something like touch missing items, like E, F, G, like that. All the missing items. He created that and then entered. And then git add and git commit and git push to his own location. And then from there, from the website, he sent a pull request to me. That's what this pull request looks like. And that is open right now. So what I can do here is take all the pull requests and see if there is a conflict. It shows me there is no conflict. I can merge all the letters and confirm the merge. And thank Brian. Thank you, Brian. And comment. And now we have a full set. So now we can bring it here. So I'll say git pull. It pulls down all the remainder. So now we have a listing containing all the files, A through Z, that are now provided to us in one fell swoop. All the missing items came through. Now let us play the exercise about a conflict. So for example, right now we have everything, and still somebody else sends another pull request. So an example would be right here. So there is this Sandeep sending S. And in our repository, I already accepted A through Z completely as sent by Brian. So I am going to attempt to merge this, and it says no conflict. That means S is missing in our folder. Is it missing? No, it is not. So why doesn't it show a conflict? Let's go see. It should show a conflict. Do we have S here? Yes, we do.
Isn't it because there's no difference in the two files?
Aha, yes, you're right. And so you're absolutely right. Yeah, yes, correct. The files, both of them are empty, so there is no difference, and therefore there is no conflict. So you can merge it. And when you actually merge, nothing will happen because there's nothing to make change. So you can see that nothing is happening when you merge. And you say merge, and you still have that same file, which is S, which did not change anything. You can see that the entry is empty, which is exactly how the file was to begin with. So a idea of opening up S, you can see that the line is still empty and there is no issue. And now we can go back here and do a pull, git pull. It will attempt to pull a tag, but it is basically a materially it did not change. You can cat S and it doesn't show anything, just like it was. However, if you actually make a material change in the body of the file, it will be a problem. Let's see if there's a problems case. And there is a conflicting file, create D, that conflicts with our D because our D has some content. If you cat D, you can see that D is for Dave. That's a conflicting file. And whereas Kalaivani did it correctly, Dave wrote D is for Dave in the body of the file. Therefore, this is conflicting. Now, if I want to correct that mistake, what I could do is go back to my folder here and modify that Dave file, this D file in the folder. And I'll say this file D, that entry, that line item I have here, I need to delete it and save. So when I delete and save, this is I'm making a local change in my computer. So I see my Git status. I see that the file D got modified. So I need to modify this. Modification needs to be sent to GitHub. So I'll say git add and git commit. I clean up D. And now I need to git push. So I push. The changes for D will go and make D empty in the remote location as well. And now that conflict will go away because our D should be empty on here, where I say I cleaned up D right there. I cleaned up D. Now I can go pull request and look at Kalaivani's D, and the pull request has no conflict because the content is matching. And therefore I can now merge her request as well. And we can finish off with the other two remaining. M, there is no conflict because M is M, as so it says M file. What does that mean? File change, this is my test file. Okay, now this should have a conflict, or maybe already had that thing. No, it did not. So now David wants to add this line called my test file, which we can accept if we agree to deviate from the specification. And so let's say we agree that we want to make this modification, even though it doesn't meet the specification. So we are deviating. Having understood that piece, we can say that, M, this file M has this item in the body called M file, and the file contains my test file. That change I want to accept, even though it deviates from specification, which is fine. So we merge and we confirm the merge. That is a addition to the file called M. So now we can see that that change also flows down to my computer when I say git pull, and then it comes down, and then I can cat M and I can see the change. Now back here, last one, which is, there are more. Merge conflict example attempt. So Junaidi is sending us a merge conflict example. And what he has done is change the file. And he says M is for merge. Whereas our M currently is, where is our M? Hold on. Where our M is cat M. It says my test file. And so now we need to make sure that this is latest. So git pull is on latest. Good. On the website here, on alpha, on M, our M says M is my test file, whereas Brian has sent a attempted conflict. And so if I want to take that conflict, I can resolve the conflict by making edits. So I can decide which one do I want to keep. In my master branch, I have M is for merge, or rather my test file. This comparison that you see arrows in this direction versus arrows in that direction are indicative of which file you want to keep. That the conflict is what is visually shown to you. Do you want to keep this segment, or do you want to keep this segment? You can decide which one do you want to keep. And we can make a decision that, you know what, M is actually not a test file, but it is for merge. So we can take that change and make a modification and then mark it as resolved. So now commit. So now M is for merge is the change that I committed, which means my alpha should indicate my M value containing, oh, where did the pull request go? Okay, I did not actually accept the pull request apparently. So let's see, now it has no conflict. And now I merge. So now I merge it, and now I should be able to see my alpha and see the M showing. M is for merge from Brian. And now I can go back here in my terminal and git pull, and I can see the change flow down to me, and I can cat M. I see M is for merge, as opposed to M was for something else like my test file. Now we can decide again to make modifications one more time and say, you know what, this M should not contain anything. You know, this is not a good idea. So I remove it. And then I have another change happening. So I say git status, and I see that M changed. So I say git add, and then git commit, and say I clean up M, and then I push. And now when I push, I see that on GitHub, my M is cleaned up again. And here is cleaned up M, nothing inside M. Now the last pull request we have is Z, and that doesn't have any conflict because Z is empty, so we can just blindly accept it. And it got accepted. We thank Chris for sending and comment and make him happy. Happy team members are good. And that's our alpha repository completely created and pulled. And all of you also can pull from the same location, just like that. So now I have a complete set of repository in that folder, A through Z created. We ignored this file, which is basically a piece of crap that Mac generates. This is a ignore file that actually decides to ignore the other file mentioned here, and the README file that describes the project, and A through Z ready. That's Git for you in a quick way of thinking about it. So let's summarize on Git before we move forward.
So Nilesh?
Yes.
I just tried creating a new file, but it won't let me because it says the file already exists in the repository. Does that sound right to you?
Yes, you can actually show it to us so you can see. Why don't you just project your screen?
Okay, share screen. So if I try to request a
yeah. So what is here, if you look at the project that you're dealing with, the project is, let's go look at, the project name is Be a Cloud Genius Alpha. So if you want to make a change, you create a new file, you don't have a permission to create, so it will fork it for you.
Okay.
Right? So you create the submitting a change will create a new file in a new branch in your fork called Sandeep Gonsalves Alpha. So you have to go to your fork. So you probably have a fork already here, and this is your fork of the repository. So this is Sandeep Alpha. In your fork, you have A and B. Now you can do whatever you like. You know, this is your property. So you can create a file, delete a file, do whatever you like, all of it. So I can create a mess and say, this is my mess. You can do anything you like here.
Yeah, but that isn't what I did earlier.
Right.
Earlier when we created
you were here, right?
Right. Yeah.
And so earlier you were here, and that location is all fully populated with all the letters. So you don't have a room to create anything.
So what if I wanted to put a request to modify one of these files?
So when you want to put a request, you should go to your home turf, do whatever you want there, and then send a request from your home turf to this location.
So the only reason I didn't have to do that before is because those files didn't exist?
Correct. Right. Let us see, create a new file and attempt to create a file called ABC. And it doesn't exist, right? It doesn't exist. So as soon as you create this file and propose, what is happening is that it is going to create a new branch in your fork.
Okay.
And then send the ABC to me. So let's go see that. Let's go see what happens now. When I go back and say propose a new file, ABC doesn't exist, so no conflict. And it says I want to now compare changes. So here the base fork is BA Cloud Genius Alpha, and head fork, meaning where you are currently, is at Sandeep Gonzalez Alpha with patch number 4. You have 4 patches. Now you can send a pull request like this, and you can send a pull request that I will receive. I just received, by the way. And so in here, if you see in your fork of the project, which is this one, you have multiple patches of the same thing. This is your patch number 4. And this contains ABC, right? And in your Tinkertoy structure, you have 4 branches now: patch 1, patch 2, patch 3, patch 4, for all the 4 different cases of your modifications.
Okay.
Is that good?
Yeah, I think so.
Cool. So I will now take control of the screen again and project. And so summarizing. What this tool did, we can use the tool in terminal, we can use it in visual editor, you can use it in the browser, all of these things. The tool is Git. It is not GitHub. GitHub is a software as a service, SaaS, that uses this software. And what this software does is allows us to manage the state of a folder where we store stuff. And we manage state means what? Whatever changes we make, it will keep track of whatever changes we make as long as we remember to commit. So we have to add and commit, those 2-step process to commit. And whatever changes we make, we can keep track in form of a Tinkertoy structure. This is a simple branch, the main branch, you can call it the master branch. You can, on your own, in your own machine, decide that I want to do a side project on this main project itself, and you can branch it yourself and call it the side project. And at some point, your side project becomes interesting enough to be able to, worthy enough to be able to merge into the main project. You can send a merge. It's not a pull request, just a merge. You can just merge yourself. It's all in your computer. So it's not a request to anybody. It is you who is doing a side project, and it is you who is doing a master branch. So all of these things you can deal with yourself without having to go to a website and do a SaaS and GitHub and pull request and all that. Not necessary. You have the permission, it's your folder, you can just merge. The command to merge is git merge. That's it. Very simple. You can use it visually in a software if you want, source free or GitHub software, merge like this. You can have multiple branches and create another side project if you like, and keep developing this side project until cows come home, or at some point you can decide that cows have come home and you can merge it. And then you merge the thing like here. And that's how this idea of a representation of what I call Tinkertoy based construction of a master branch, that you can traverse any direction. It doesn't necessarily go this way or that way. You can traverse in any direction. You can also jump like this. I decide to go here. That's also okay. You can also branch out and have a side project going, and at some point decide to merge it here. That is also okay. And have multiple side projects going and merge it here. That is also okay. Any structure you want to put together is basically possible because we are storing our state of the folder in these Tinkertoys, in these SHA-1 hashes. And that SHA hash gets created when you add and commit. That's the core idea to remember. And this is how you individually use it. You can also extend the same idea to work with a team and collaboratively operate on a project just like that. We use the example of using this software as a service. It is a commercial software. It is mostly free. There are other competing software like this called Bitbucket, which is also good and somewhat free. There is a open source software that is very easy to deploy like SaaS. It is called GitLab. That's what Boeing company uses internally quite a bit. And so you probably have access to GitLab already, which is this product, GitLab, that you may have seen already in your company, or if not, you will find out. But that is what Boeing runs internally to manage your software. In this, pretty similar to GitHub, but it is open source, and that's what you use. You may have seen it or used it already, I suspect. So that's a brief on GitHub. Now, having discussed this, I'll take a short break, and then we'll switch over to the idea of using a platform as a service, and that is an exercise. It begins in this location. I'll just point at location and then start a break for a few minutes. And the exercise I want to do right now is going to be here, coming up. It looks long, but it is not long. So it begins at this point, module 15. That's where it begins. And that link is here. And so we will begin from that point. We can rapidly go and finish it off today. If I think we can do it. We still have enough time. So we should be able to do that after we resume from break. The timer starts now. Sorry for the delay, guys. I think we are back. Yes, I see people active. 1, 2, 3, 11.
Yep, I'm back.
Okay. So you had a question about what is the command to issue the VM to connect to a repository in GitHub. So let me describe that idea. You can, it's a general purpose way of thinking. That's what I described, as opposed to giving you the command. So the idea is that you have, say, a repository here. And so every repository can have multiple remotes. You can find them by git remote -v command. So git remote -v will show you all the remotes that you have for a repository. You can git remote remove also. So you can add and remove remotes if you like. Say, for example, I want to remove this remote. So you can get rid of the remote. You can have names to these. So a name could be origin, for example, that points to some place that you like. So this place can be GitHub. You might have another name for something like, Bitbucket. So that will point to bitbucket.com. And you can have another names. Say, for example, here, I want to send my repository, the code I have, to the Microsoft Cloud. So I can then have this remote point to Microsoft. And that way you can label the remotes and have a place for them in the remote location. Now to add a remote, the command is git add remote. And then the link. The command to remove a remote is git remove remote, I think. I'm not sure. I'll find out. The command should be git remote remove, something like that. Yeah, that's the command. So you can then git add remote add, and then a name like origin, for example, and the link. That's the way to add a remote. Similarly, git remote remove, and then origin for the name that you want to remove, or maybe you want to remove Microsoft, or maybe you want to remove Bitbucket. That's the way you deal with it. You can add and remove links if you like. You can have multiple remotes, and you can remove any number of remotes. You don't need to have any remote at all. It's all local to begin with. And so none of these remotes are required. Don't need to have any of this. And so it is totally optional, but a very nice thing to have. If you have a remote, you can push and pull. Push and pull between the location remote and your computer. That's the idea behind using remotes. So that answers that question. To get the exact command sequence that you want to use with a repository, you go to that location in GitHub and you create a new placeholder like this, and then it gives you. So if I say type in this name and create, and then it gives you that link right there. That's how you create. I don't want to create this repository, so I want to basically delete it. So I'll go and delete that one. And that's gone.
Great, thanks.
Okay, now let us begin creating an account on Heroku. That's what I intend to do. So I would like to use the machine that we have in the cloud workstation that we have. So here is a workstation. I would like to operate inside that workstation ideally, because I must caution some of you that have Macintoshes. The idea is that these Mac people, they fall in love with their Macintoshes, and they tend to not use the workstation. And I'm one of them. I'm a culprit. I'm not saying that it is a bad thing. I'm saying that it might accidentally destroy your Macintosh because you are new to these things. So that's what I want you to pay careful attention. Sometimes these terminal commands can be disastrous. If you don't know what you're doing, it might cause havoc on your beautiful Macintosh. And that is why when you're doing it the very first or second time, I suggest that you stick to the virtual machine, this one. Yeah, that is going to be much better, because you can create mess, total mess here, and it doesn't hurt anybody. You can destroy the VM, create another one, no problem at all. That's the way to go when you're learning. Like 1 or 2 times, just deal with the machine, please. And then when you're happy with it, when you know what you're doing, when you know what files get installed, when you know how to deal with the Mac, the Macintosh command line and binaries and Ruby and Python and God knows what will come up. It will come up and it will get installed, and you don't want necessarily to have unnecessary stuff loaded on your computer, which is a nice thing to have in a clean computer. So keep it clean, use the VM. That's my suggestion. And if you still want to use the Mac, you're okay. You're welcome. I might help you, but I don't guarantee that I will actually be able to successfully help you in fixing an issue that you will run into, but I will try. I think I can deal with it. I still prefer that you use the virtual machine, because it saves me trouble. So having said the VM in the terminal, that's what we'll play today. And what I want to do is go to this site called Heroku, and there I have an account. You should create one. It is free. It will not ask you for a credit card. And even if it does, don't give it to them. Not necessary. Now, when you sign up and you log in, I should log in. I already have an account. So I'll log in like this. And now what we need to do is, first thing is to establish a relationship between that service, the platform as a service, and our laptop, our terminal, our command line. That's what we intend to do. That relationship is established by using a toolkit. This toolkit is called Heroku. We have a bad link here, apparently. Interesting. So that link is bad. So don't go there. Instead, go Heroku and Heroku.com, and then create an account. And then we have to install this tool belt. This tool belt is a piece of software provided to us from the company Heroku, and that gets installed like this. That's the command to install it. So we'll follow that simple one-liner, not in this terminal, but in the workstation here. And so this is a piece of software that you may not want on your Macintosh, by the way. So it's not necessary unless you are going to regularly use Heroku. This piece of software is not required. So I will run it in the virtual machine. And so it goes and downloads something. and it says, give me your sudo password, and the password for sudo is Cloud Genius. It is on the wallpaper. So I'll type the password and let it proceed to install Heroku toolbelt. That is what is going on right now. When Heroku toolbelt gets installed, it gives us a command line idea. The command line that we get is called Heroku command. That new command pops up. And we will use that command to authenticate our terminal with the Heroku service. That's the first connection we have established between our, let me get a new sheet of paper here. New sheet of paper, Heroku. And what we are doing is from our terminal, we are establishing a relationship with a platform. First thing, we install the toolkit and then run the toolkit through the command called Heroku to establish a link between the Heroku cloud and our laptop. This Heroku cloud is a platform as a service. And so that relationship is established like here. Heroku, authenticate me with login information. And that's what I'm going to do here. And there it is. It asks me for my password. So I'll have to give it my Heroku login password. So it says, give me your email address. So I'll say, here's my email address. And then it asks me for my password for Heroku, which I don't remember. So I will find out. And then copy my password. And here it is. My password is, I'm going to copy from here, go to the terminal and paste. So I pasted my password and then it says, yeah, logged in. So this terminal is logged into that Heroku account that I have, which is a nice thing to have. Next thing is that I want to be able to do is send a key to them. So the key that I have, which is already here, by the way, this key that I have is in my .ssh folder. It's already there. So I want to use it and use this key, this private key and this public key. I want Heroku to use these things so that I don't have to type the password all the time. So what I need to do is go back here and run this command. I think it is better done side by side. So I will go side by side, 50% and 50%. Come on, 50%. There we go. So we can do this much more efficiently with side-by-side views. So I want to add my key pair to Heroku. This key is what is going to be happening is that it's going to look up your key pair. It says it finds a key pair in that location. Do you want to use it? I say yes. Use it with Heroku? Yes. So I say yes. So it sends it. It sends the public key over there. And now we are done. So from the connection establishment and security key perspective, we are all set. Next one is that we have to start building an application because we are going to be a developer. We are going to use a platform. We are going to create a very rudimentary, simple application using a Ruby on Rails framework. Now, this is something that you may or may not be familiar with because I don't think most of you are developers, but some of you are. So if you're not a developer, let's understand these things a little bit. The idea in a development situation that you are using some kind of a language, and this is how you write your application. Now, if you start writing your applications, all of it by hand using a language, it will take you a lot of time. To simplify all that, what you do is go look at giants. And you basically stand on the shoulder of the giant, like here, or maybe here. So, and then use whatever the work that they have done already for you, and then you become efficient. So these giants are people like, for example, this guy. He's a giant. He created a thing called Ruby on Rails, this gentleman. And so he works for a company called 37 Signals. I think they have a new name called Bootcamp. And so several years ago, he created a product called Ruby on Rails. And so you should be able to find it, not here, this site, Rails, Ruby. Yeah, this site. So this is the product that we are talking about. It is in its multiple iterations. It is also open source on GitHub. You can find it github.com/Rails. Should be able to find it very easily. And so that's the piece of software I'm talking about called Rails. Is a ready-made framework. Lots of code that is this person, his name is, what's his name, DHH. He has already written a lot of code in Ruby on Rails. And we want to use that piece of software as a platform, as a foundation. And that by doing that, it simplifies our task a whole lot, makes us efficient. And by the way, this kind of a method is existing in every single programming language you can think of. So if you say Python as a language, you will have a bunch of platforms available to you like Flask or Django, and there are more. And so you pick your language of choice and you put your language here. There is going to be a ton of frameworks available to you that you should absolutely use. And to add to your complexity, if you choose JavaScript language, there is a nightmarish number of frameworks available. Nightmare. It's a nightmare. It's nightmarish. Nightmarish number of frameworks available in JavaScript. So that's another challenge to choose the right framework, but we're not going that direction. All I'm doing is saying is you select a platform so that it expedites your work, makes you efficient. Now, by choosing a platform, what happens is you have to follow their way of doing things, like the Ruby on Rails way. So there is a Rails way of doing things. And that's what we have to follow if you're choosing the Ruby language and Rails as a platform. So we need to know what Rails way is, which is basically their documentation. It will provide elaborate detail as to how to use Rails if you go that route. And our idea is to use Ruby language and use the Rails framework to write a simple application and then put that in a Git commit and send it push, a Git push to Heroku. That's all we need to do today. So we have set up a method for us to push. This setup has been set up already, but we haven't actually pushed, but we are logged in and all that good stuff. Now we need to build an application, then put that in Git repository. That's what we intend to do. Now to build a Ruby-based application, we have to use this framework, and that's what we are planning to take in that direction. So taking steps in that direction. When we use this thing, this is a piece of software. And so any Ruby software is delivered to us as a gem. You can see, how gem looks like. I don't know how to draw properly, but you can see that these gems are available here. Lots of them in this site. Lots of gems available. There are like 13,500 million, 13 billion downloads of Ruby gems, a variety of gems. So Rails is one of them. And Rails has 93 million downloads. It's a very popular gem, or a very popular software. Gem is basically packaged software in Ruby. So that's what we're talking about, a gem. So Ruby is a gem, and we're to get that gem installed. And to install a gem, we need to run something called bundle install. That's the command to install something. But what is this bundle command doing? It is also another gem. The gem is called bundler. So bundle is a action, bundler is the gem. Let's see if it's here on the James on the Ruby Gems website. Do we have bundler? I bet it is there. It's 162 million downloads. So that's the bundler version available. So we need to get bundler and then bundle install something to get that other gem. So we want to bundle install Rails, we can get Rails. Bundle install whatever, we get whatever. And so this machine, does it have the bundle command? Let's see, gem list. Do we have lots of gems already here? Apparently so, but do we have a bundle command? I think so. I I have set bundle command already for you. The machine is ready for that. So we don't have to worry about setting up Rails and Ruby and all those things. It's already ready, done for us. However, I have left certain portions of this exercise for us to do in here. And our idea would be to bring this thing down onto our machine, which is what this gentleman, DHH, has done for us, is given us Rails as an application. So we want to install that particular gem using the gem command or using bundle install command. There are two ways of doing this in this instruction. I'm using the gem command to install something. Otherwise, you can also use the bundle install command, which is also we'll do in a subsequent step. Simple step of installing one gem is to gem install that name and a version number that you need. So I want to use the Rails gem and I want to use a specific version number like 4. I will use that command. So that's the idea here, is to install that particular version of Rails. So we'll grab that and run it. It's very simple. This exercise is very simple to do and just copy and paste most of the time. So you go to that Ruby Gems website and it is going to install, download and install that particular version of Rails from the Ruby Gems website, which is Ruby Gems is here, and there you can find Rails. So when we say Rails, it automatically goes and gets 510, the latest, but I want to get the older version. So I wanted to get what version I have. I think I wanted to get was 4271. So that's the version I wanted to get, 4271, which is what I obtained. It is this version here. And so that's the version I obtained. So I can specify whatever I want. It will go to this location called Ruby Gems and download it, set it up, prepare it for me. So now I have Rails installed. It tells me that it installed 19 gems. I just wanted one. It gave me 19 gems. This is happening because Rails requires these gems, 18 other gems. So it installed not only Rails, but also installed 18 other dependencies that Rails needs. So now you have all the things Rails needs automatically. Having done this part, what I want to also do is to be able to help us understand that the way our platform as a service operates is that it requires and expects us to use a database. So this Heroku thing, no, not this Heroku, this Heroku. Where is Heroku? Yeah, it's loading up. These guys have a requirement that we should use a database, a specific type of database with a Rails application. That database that they suggest that we use is called Postgres. And so that's the database we need to have, and we don't have it. So we need to get this database installed, which is simple, but we just have to do it. So the way to do that is to basically install the database itself by running these commands. Prepare Postgres database. So we will do these steps. By the way, you will notice that there are certain instructions here that I'm skipping because these are instructions provided here. Like for example, remove something is basically written down here in a fashion like this because people who do the program, this bootcamp, repeat these exercises so many times until they get it. Is that they might have a exercise halfway done and they will come back and do this and then they will cause conflict. And therefore, this method that I have, this statement that says delete any stale folder, it's basically for them. You probably don't have this folder called my app already, like I don't have it, like you also don't. So if you say ls-al in my app, you will not find it. There's nothing. And so that is expected. If you're doing the exercise first time, you will not have it. If you do it the second time, you will have a folder called my app. And that is what I am deleting here, is to remove that. It is not necessary. So that's why I'm skipping that portion. And the idea is to be able to, when you repeat that exercise, you want to begin from clean slate. That's a clean slate right there. Delete the old structure. This is where the application is going to get created when you run the steps. Now we install a database. So for that, we have to go to the operating system source, a place where operating system will send out binary distribution of a particular software. in our example, we are installing PostgreSQL, and that's the idea. So we'll first of all update our apt cache like this, and then install Postgres. So that installs Postgres database because Heroku says so. Now don't install this on your Macintosh because it will not even run because this apt-get is a Linux command. If you want to do this on Macintosh, which you should do the second or third attempt, not right now, is to use brew. Brew for your own Macintosh package management, this one. That's a suggestion, not for the first time. Second or third time, yes, I will help you, but not in the first run. First run, you go in the virtual workstation. Back here, you could use brew, but not the first time. And now we will install this PostgreSQL, which is what we intend to do in the workstation here, and install Postgres. So it will install Postgres database. It becomes a database server. And why are we doing this? Let's go understand it. So the reason we are installing this Postgres is because Heroku says so. But that is not enough for me. I'm not happy to hear that. You demand and you require that. Why is that? So the reason why we want to actually have Postgres in our laptop, which is kind of ridiculous, like it's a full-fledged enterprise-grade high-end database server, and you're putting that on a VM. Why? It runs on Heroku and all that good stuff in production, and that is nice to know, and you have Rails running, and you have Postgres database running, and all that good stuff, but why do you make me run it here? That's the question I want to understand. Why can't we use a simpler database? Why run a full-fledged enterprise-class database on one laptop? The reason why we want to do that is we want to keep our environment identical in every step of the way. As you begin a new project, at the very same time, you should think like you are going to be developing for production, not just for development, not just for staging, not just for testing, not just for whatever else you might have, X, Y, Z. It doesn't matter. You think always production. Whatever you intend to have in the final game, that is how you should begin. Exactly like that, to the closest possible manner you can get to, for not only yourself, but everybody on your entire team should be running exactly what you have in your company has in production. Now it's hard to pull off, but that is a benefit if you are able to have everybody work the same exact fashion with the same exact version number, the same exact set of dependencies. That reduces friction in your team, in your company. That's something that we'll talk more about in the second segment, and actually practice and regulate behavior. And, that's the idea of DevOps. And we'll discuss more about this next. But right now, the idea that we are really driving towards is to make sure that we are mimicking exactly what we have in our production. So if the production requires Postgres, we will better have Postgres on our virtual machine. And that's what we just did. This VM now has Postgres. It runs. And that's the primary reason. So in that Postgres database that we just have, we have to create a role and a database. This was a server installed. It runs like a server. So this machine that we have, Cloud Genius Workstation, is running like a PG server. In that database server, we need to have a role and we need to have a DB. The DB will store data. Or rather, we could store data. We don't need to store data, but we need to have the structure in place. And we will probably not use the database, but we need to have the database structure, to have the database server to mimic the production environment as closely as we can. And with cloud, you can actually very easily accomplish this. With virtual machines, it's fairly easy to simulate the exact same setup. And as you will see more examples coming in that direction. But right now, a role and a database, a place to hold data in your database server. is what we intend to create. That is this step. So create a role and a database. So here's the role creation. So you have to first log in as Postgres user and then create a user, which is what I am attempting to do right there. Okay, so here, create a user. And then it asks me for the password. The Cloud Genius password is Cloud Genius. What? It didn't ask me, I just unnecessarily typed a password. Okay, it did not even ask me for a password. I was confused. But there was no need to type the Cloud Genius password. It was not asking me for one. Okay, so that's why this command not found. It's not a command. I thought I was typing a password, but no, it did not ask me. Then we have to create a role and a user. The user I want to create is going to be called user. That's the username I have chosen. And that is what I intend to do. And so what we want to do is create user interactively. And here we go. And so it says name of a role to add. So the role I want to use is user, user. And you want this to be a super user, and I'll say yes. So grant permissions, yes. And that's it in this step. Next one is what I will do is create a database, a place to store data. And that is this line. And you remember that we are doing these actions as the Postgres user. This username is Postgres, not the regular user. The regular user is somebody else. Who's that somebody else? Let's go see. At the top, you should be able to find it. If not, we'll exit from here and we'll compare. The regular user is called user, and the Postgres user is Postgres. So we change the user in this step. Now we can operate on the Postgres database server by changing the user logged in user. Now we have to create a database called my app development. That's what I will do, is create a database called, I did not copy properly. Copy and paste. No. Copy and paste. No, doesn't want to copy. Okay, I'll type. It did like 3 times. Oh man, break it. 3 times. So late. Okay, I pasted and I create a database called my app underscore development. That is the place to store data for my development setup in the laptop. Then I exit. When I exit, I come back to my regular user, which is the user, this one, user as opposed to Postgres user. So that temporary transition I did to mess around with my Postgres database server. Now I'm done messing around. I created a role, I created a database, I came out, exit. Now we need to have another gem. That gem allows Ruby to interact with this server. And so for Ruby to talk to this PG server, we need a gem. The gem is called PG. And that we need to install. Otherwise, Ruby language will not be able to talk to it. So that gem is here. And that gem requires another piece of software, by the way, which is called libpqdev. So that library for PostgreSQL in its development form needs to be installed on the laptop before you can install the gem. So here is that piece of software necessary for the gem to succeed, and then install the gem for PG. So this gem install PG will get the PG gem from Ruby gems and install, and this will take about 2 minutes roughly. This is building native extensions. Whenever you see this line, it takes time for the CPU to run and compute. So it did finish. It installed the PG gem, this version, on your list of gems in this workstation. And now you have a way for Ruby to interact with your database server. Now we are ready to create an application. Now, the work we have to do is to create an application has already been done by this guy. He already did the work. We are just playing around with it. And the play around is very simple. When I say create an app, actually I'm asking Ruby on Rails to create an app for me as opposed to me creating an app. So here, create a new application using Rails. So I'm saying Rails, please create a new app called my app and use the database just like Heroku does in production. Use a database server called PostgreSQL. I would like you to use PostgreSQL. If you don't specify, Rails will choose something else, default SQLite database, which is not what I want. I would like to have matching my desire exactly in line with what the production machines will use. And therefore, I'm calling out to Rails saying that, you know what, you should use this database, please. And that is what I want to run. And one word of caution, which is anytime you install a bunch of gems, like gem install this, gem install that, this virtual machine is configured to use RBENV. It's a piece of Ruby management. And you can see that it has versions of Ruby installed. There are two versions. One is a system Ruby, and the other version of Ruby is 2.3.1. Now, this piece of software, RBENV, requires that you tell RBENV that I just have added a bunch of gems. And so the way you tell that you want to rehash your gems. So it says RBENV, please rehash your gem list. And when you do that, all the latest added gems will get recognized by the RBENV software and will work correctly with the Ruby installed. So that's a step that you don't want to miss. I have it written down up here already. Rehash your gems. So I ran that step here. And then I proceed next, which is to create an application. To create an app is simple. It's like this. And I'm telling Ruby on Rails to go create a new app called my app and use the database Postgres, just like Heroku wants me to. And so here we go. It creates a bunch of things and prepares and installs and bundle installs and lots of dependencies. And a new folder gets created called my app. You can see that this my app folder is actually here, right there. And you can open it up in Atom Editor while this thing is actually installing on the other window. So Atom opens up. The other window is something you can close. And you can see that a bunch of things got created automatically because this thing is running and installing the application that you just created and sets up all the dependencies that Rails requires for that app. So that is what is going on right now. And it is installing the bundle, which is a package of list of gems. You can see that list here in gem file. And that's a list of things that we need to use, and that bundler is actually installing right now. And what I will describe, this gem file is a critical file that you need to keep in mind. And what this does is basically gives a list of gems to the bundler command. So that while it does install the dependencies needed, I will talk about gem file. The idea of creating what we just did is we said Rails, create a new app called my app. And by the way, use the database for PG. So remember that. And you create a new app. Now, when the Rails creates a new app, it creates a bunch of things in here, bunch of files in that folder. And one of the files is called gem file. That's the name with a capital G. And in that file, if you see, you will find a listing of all the gems I need. Now, once that gem file is ready and all these files are ready and created by Rails, what Rails also does for you as a convenience is it goes ahead and runs bundler, meaning bundle install. And bundle install, what it does is goes to this gem file and looks at all the gems needed and goes to the location known as gem Ruby gems location. Where is that? Movie gems location, and grabs all the gems needed and installs them. And that's what it just did. So it installed a bunch of gems for us because we actually installed our new application. We said create a new app called this using the database PostgreSQL. So it created an app. The app looks like this with a bunch of files in there. And the files are, there is an app folder which has some assets and controllers. Oops. Don't move. I will use the mouse, not the pen. So, okay, come on, don't move files around. Yes, thank you. And so controllers, helpers, mailers, models, views. This is the application that is already pre-written as a skeleton for us. In addition to that, there are other things like bin and configuration and database and libraries and log and bunch of other creations that Rails just created for us are now available to us for use. In addition, Rails also had this file called gem file, which contains a listing of the gems that Rails version, PG version, SAS Rails, Ugly Fire, Coffee Rails, jQuery Rails, Turbo Links, Builder, this and that, and more. So we wanted these gems to be also installed because our application will require these gem packages that are available here on RubyGems website. So it did for us all of that thing already. We don't have to do it ourselves. And that is our application skeleton, ready for use, thanks to DHH. Now, this step that is mentioned here, which is spring stop, is necessary only if you see that this command that you ran before, if it gets hung for some reason, you want to break it by Control C to break it, and then say spring stop. You just stop Spring Server like this. It is not running, so it is not going to be issue. But if it does, you need to stop that. Remember to stop that. And next, well, we now have an application ready. I want to see it now. But I don't want to just blindly run something without actually understanding. So I want to understand a little bit about what is that thing that just got created. And that is what I intend to do. So what I want to talk about is this idea of what is known as MVC. I am suspecting those of you who are developers already know what this thing is, but others may not have an idea. So if you know what MVC is, please chat and tell me that you know. But I would like to give you a brief 5-minute overview of what this thing is to help us understand. I'm looking for responses. So model view controller. Yes, that is great. That is exactly what it is. And so those of you who are familiar with this idea, it's nice to know. Just hang tight for 5 minutes. I'll describe and so make sure everybody understands what this thing is because it is important. Good to understand what's going on because we just randomly generate an application, but we have no idea what the application is going to do. So understanding is important. With that, here we go. So MVC, these are a way of constructing applications in a systematic fashion. Now, this M and V and C stands for 3 different things, by the way. Controller, view, and model. So now that you know the names, that is clear that this piece of code that we have, the bunch of code that we have in the My App folder, is basically divided into 3 parts, 1, 2, and 3. So you can see that these 3 are actually independent folders right here. There is a model folder right there. There is a views folder, and there is a controllers folder. There are some other things also, by the way. So just leave them alone for now. But the most important things are model, view, controller. Those 3 things are clearly separated, segregated in form of separate folders, and we already have them crafted like that. The reason modern programming does it like this is to simplify understanding and clearly articulating separation of concerns. The piece of code that you write in this folder should deal with the data structure, the data, the idea about data, anything to do with data, basically. That's what the model is supposed to be doing. So if you write some code that deals with the data, you write in this location. Whatever you write that makes the look and feel of something, like how it looks, how it feels, how it responds, is a different idea. Respond is here. How an application will respond is a logic part, the action part, the decision part, the control aspect. Those aspects will belong in the controller folder. The look and feel, how it views, how it looks, that segment is stored in this folder. Whatever you see is a view. Whatever is the action in response to something will be the control factor, or the decision maker, or the logic. That is what is stored in the controller folder. So this is a simple way of separating concerns. Now let us look at an example. Let's say I have in my home a place to store dogs and cats. Now I am in a shelter, and I go to the shelter and find a dog. Oh, that dog looks nice. I want to adopt it. So I bring the dog home. And so now I suddenly have one dog and 0 cats. Then I go to the shelter again and find a good cat, and I bring the cat home. Then I have suddenly a change in my data, and I have 1 cat, 1 dog. So whatever I'm storing in here in form of data and the structure around it is my data model. Whatever I store about the application is what is the data model. So it goes in the M part, MVC M part. Now I would like to write an application that opens up in a web browser and shows me how many dogs I have, like by picture, like D and C. So if I have 2 dogs, it will show me like this. And if I have 3 cats, it will show me like this. So this is my view. And that's my code that I need to write that will make my web browser look like this. The view is what is the piece of code that will show the user a representation of the data model. Right? Those 2 aspects are clear. Now let us see what happens. Is that the idea of, on one hand, you have a view, and on the other hand, you have a model. The model, you have a structure to store dogs and cats, and you say 2 and 3 and like that, and the view shows something like this. Now I decide to go walk the dogs. So in my home, these 2 dogs go out of the home. So my view should change because those 2 dogs are walking with me. So they're not in the picture. They're not home. So this is whatever my home view is my home model is. So when I take the dogs away to a walk, my view changes, but it doesn't change by itself. There has to be a logic that controls it. So that logic or the control part is stored in a folder called controller. And it's separated in a separate file in a separate folder called controller files. In the controller folder is how code is separated, so that it's easier for a reader to understand where the code resides for which segment. And so a controller will actually make those changes when the dogs walk outside and they're going to go out. So you say modify, make it 0, and remove these pictures. So make them blank like this. And that change is controlled by the controller. So it operates on the data structure and then make sure that the view is updated. So the view will then look at the model and reflect the current state of affairs, which is no dogs in the home. That's the kind of idea behind MVC. There are more such patterns of writing software, and you can talk and discuss more of these things. You can read more about it here, MVC alternatives. There are lots of them. So people come up with their own methods. You can read more about it. So there are these MVP, MVVM, God knows how many people will come up with these things every other month. But we are discussing an MVC right now. And so you can see that there's a folder called controller in which there is a application controller, which has some piece of code already written. There is a model folder, which is basically empty. And there is a view folder, which has a layout for the application. And this is how it looks like. The look and feel is written right there in this piece of file. The file is called application HTML ERB. This ERB is a Ruby template, and this file is written in ERB format. It's mostly HTML, but looks like it can be modified by Ruby language. That's why it's called a Ruby template. So that's the kind of structure of an application that we have been given by Rails. And that's the brief discussion on MVC. And then what I want to be able to do is create an app that is mine as opposed to something that is given to me. So I have to make some modifications here. So I'll make some modifications. What I want to do is basically generate a page that shows me what is the time right now at the moment. Like, what is the time right now? For which I need to create a welcome controller, a controller that will open up the front page of the website that I want to create. And in that site, I want to see the time right now. And so to do that, I need to generate new code. So for that code generation business, what I need to go do is run Rails again and tell Rails to generate a controller. And that goes like this. You say Rails generate a controller called welcome. So Rails does it. We'll say Rails generate a controller called welcome. So it generates it. We are not in the right folder, by the way. We need to go to the My App folder and then run it. Rails generate a controller called welcome. So it did. What it does is systematically creates application controllers, welcome controller in the right location, controllers folder. It creates a view called welcome view in the view folder. It creates a welcome controller test case in the test folder. It creates a helper in the helpers folder called welcome. It creates some assets like welcome.coffee. Coffee is basically JavaScript modified. So it creates a coffee script, which is basically going to be converted into JavaScript. And here it creates a SCSS. This is a simplified version of CSS. So think of it as CSS. Think of this thing as JavaScript is what we have been given, dynamically created when we generate a controller for welcoming somebody on the front page. And that's this step. Next one is going to be modifying the look and feel of what we have in our welcome controller. So we have this thing created already here called view welcome. I want to go there, and then in there, I want to edit a file. So if you go here in the Atom editor and make sure that you open this particular folder called the My App folder in Atom, which is what you see, you will see that in the view, there is a welcome folder which contains nothing. So in that folder, I want to create a new file called index.html. So I'll open a new file here like this. Okay, come on, open your file, please. Okay, file, new file, and then save it in the application, views, welcome, and the name should be index.html.erb. That should be the name. It's given right here, by the way. So I save that file. It's an empty file. It shows up here, and I want to fill it up. Fill it up with what? Some sample code. The code I want to show is this. What this code does is very simple. It just shows me the time of the day right now. Actually, the time of the web browser at that location. Not right now, but that location. So whatever your geography is, it will look up that time and show you at the local computer time at that location and say, hello, Cloud Genius. The time at this moment is time.now. This is a Ruby representation of time, and it will be converted into English representation after evaluation of this expression. So you will see actual English time here, and the Ruby time will go away. And that will happen when Rails will run. So we want to run Rails now. We have this going. We have a look and feel constructed, very simple look and feel, just shows time. And now we want to make sure that when we run Rails, that this particular view opens up. So for that, we have to specify a route. A route is basically a method, a system of telling Rails to open something when something happens. So when people open the slash portion on the front page of the website, the slash, like for example, the slash portion of the website will be something like b.a.cloudgenie.us followed by slash. That's the main page. So you can open up this page when people visit the slash page. What needs to happen is I would like them to be able to show the welcome index page. That's what I would like to happen. So for that, I have to tell Ruby to modify the routes. Ruby stores its routes in a configuration folder, which is already available to us in here, config routes. And in there, it has a commented out entry already. We have to go look for it. This entry is right here, line number 6. We have to uncomment that entry like that. Remove the comment. Now save it. When you do that, it knows that the root of the website, when somebody opens up, that you should show them welcome index, meaning you should show them the my app view welcome index HTML ERB. This representation should be shown to them. That's the routing that we have set for our Rails application. That's what I just did. And now it enables our root route to match the welcome index page. This may be new to some of you who are new to application writing, but it is actually intuitive if you think about it. So whenever opens the main page, show them this piece of code. And that's what we'll show when we run Rails. The next. We are almost getting ready to run it. So we are going to run it now. And here we go. So how do you run Rails? We just say, Rails, please run a server for me. So Rails runs a server for us locally, right here on the laptop. The Rails run a server. So it runs. It opens up a Rails server. It is running right now. It tells me that it is running on this location, right here. On the local host port 3000, we should be able to see a new Rails application running in the browser Firefox on your virtual machine. Locally, go to localhost and port number 3000 slash, and it should show you the time. And here it is. It says, hello, Cloud Genius. The time at this moment is time.now. Time.now converts to this time representation of right now. Right now it is in the computer, which is running here. It is in GMT time, Universal Coordinated, and the time is London time, and it shows the date is 4:29, which is what is in London. The time is 1:41. So that's what you see from your computer. This, by the way, the virtual machine is in London time. I set it like that. It is set for UTC because people all over the world can use it. So we would just want to have the standardized UTC time set, and that's what it's set for. And the time is that. It shows, it runs. So it runs here. And so what we want to be able to do is break this run by pressing Control C. So we saw Rails application running, and that is all nice, but I want to run it on the cloud, not here. So what do I do now? Let's go understand that. Now that we have an application ready and it's there on our laptop and it runs in Rails, I want to make sure that I package it up and send it to some platform as a service for them to run it. And so that next step is simple. All we need to do is put this in a Git repository and then send. But before that, there are a couple of changes that Heroku wants us to do so that it understands what package you are sending. And these changes go like this. So in our gem file here, which is this atom editor should show us the gem file. It's opening up. This file, we have to be diligent in making sure that we are making changes according to what Heroku documentation requires. This is a platform as a service requirement, so you have to meet that. Otherwise, it will not run, it will not function. And that is what I am doing right now, is following the documentation requirements or the requirements given in the documentation by Heroku. And they suggest that you modify your gem file and include this gem called Rails 12 factor. That's the very end of the gem file. We need to have these lines. So these lines here, and I see a typo. And I'll fix it. I'll tell you what typo is, and I see it, and I will tell you why it needs to be fixed. The typo I see is that we have a version of Ruby mismatch. The version of Ruby I'm running here is 2.3.1, whereas the command here is 2.3.3. That's going to cause trouble. So that is what we need to fix. So simply, we don't want to change the Ruby version. We just use 2.3.1. Instead, change this to 2.3.1. That's simpler. So we'll make these two lines at the end of the gem file. And when we go, copy this to the gem file, which is at the bottom, gem file, go to the very bottom, at the very end. And at the end, I will create some room and paste. And when I paste, I want to make sure that I change that 2.3.3 into 2.3.1 to match my Rails, so Ruby version. Match my Ruby version is what I needed to do. So I will also make a change in the website. That is a whole lot simpler to avoid any confusion. So updating my website right now, here we go, and boom, done. So there is no confusion anywhere now that the typo has been corrected, that you should be able to see the exact thing that you need to use. So there is no need to worry about this typo anymore. So we added the gem Rails 12 factor and specify the version of Ruby used. That's what we did. Now we have modified our list of gems needed, which means we need to update our bundler. We need to tell bundler, please update. So we'll say bundle update. It will go and get that Ruby 12 factor missing gem. This one was installed. You see that installing Rails 12 factor. That just happens because we added a gem. Now that we have updated the bundle, next step, we have to go modify a couple more things. For example, this particular application runs in the context of the user. And who's the user? Who am I? I am user. My login name is user. And so this user login could be different from different people, right? And Heroku has no idea what the user is. Like, they don't know what your username is. Could be Nilesh, could be John, could be whatever. And so we want to basically anonymize the user, because that user is specific to this machine. I want to make it run anywhere I like. And that is what the change I have to do, to make it run anywhere on the planet, irrespective of the name of the user called user, which is what I am right now. Who am I? So that change is what I want to do in the database configuration. So I'll go back to my Atom editor and look at my configuration. here. And in the configuration, I will expand to find my database YAML. This is a long file, by the way, so just don't get scared. Most of it is comments. And what you need to do is carefully look at the, the line here. So you have to read this line called username my app. You have to remove that line from this file. And you can find that line here somewhere called username my app. At the bottom, it should be right there. This line should be removed. So I remove it and it goes away. Before I remove it, I want to make sure that this line doesn't exist anywhere else in the same file. So I will press Ctrl D to check its existence of the same thing again anywhere else, and I don't find it, which means this is the only occurrence of this line in this whole file. So I can delete that line carefully. And when you are editing these files, be very careful. Sometimes virtual machines don't respond in time, like it is not responding to me right now. That's just bad. But now it did. And I deleted that line like I have required here, remove that reference. And now that why remove that line is basically this application is called my app. And the user is user, and those references, we are basically anonymizing them. So I'm saving this line, saving this change that I made in the Atom editor, and save and quit. And now the file should look like this at the end. You should cross-check that. The file should look like this. And it looks big right now, but it looks big because there are lots of comments. So if you look at excluding the comments, it actually matches. The default section and the pool 5, development section, database my app development, and then test section, it matches, and then the production section. Production section also matches, which is nice. That match has been confirmed. That means our database YAML is good. We should be able to proceed forward. And now arrange to use this in a Git repository. So this whole thing that we have here, all of this should be in a Git repository. So it's very simple now. Git init right here, and then git add everything, and then git commit my application. Works locally at least. And I'm going to commit. So I just committed. Now what? I just git status. Status is clean. Git log. I see that. My application works locally. I want to send it to Heroku now. To send it to Heroku, I need to establish a remote connection. A remote connection. How do you establish a remote connection? You say git remote -v. There is no remote connection here right now. And so we want to establish a remote connection with the Heroku platform as a service. So we don't see anything right now. Git remote -v is empty. So we'll say Heroku, create a placeholder for me, please. It goes and creates a placeholder on the cloud. And the placeholder we got is called, it generates random names, by the way. The name that they have given us in this instance is sheltered-shore-11268.herokuapp.com. That's the randomly generated DNS name that Heroku just assigned to my application right now. And so now they also have put in a remote file, by the way. So git remote should show us a remote. So there's a remote here, 2 remotes. This is one for fetch and the other one for push. Those 2 remotes are set already because Heroku did that. They created a placeholder. The placeholder is this thing, which is a DNS name. And we need to generate this dynamically generating DNS name for our own platform when in the next exercise, we will have our own platform as a service. So we need to have the capability to generate our own dynamically generated a DNS name like this, and we should have that capability. So this is called a wildcard DNS. What I would like to do is construct something like a wildcard something like this. And so if I have a wildcard DNS in place, that's what Heroku has. What I will be able to then do is generate a place for an app that looks like here. Like this. So some adjective, some name of a scientist, so randomly generated a wildcard that I will substitute for this asterisk that I have in line number 9 here. And then dot platform as a service dot Chris J. Taylor dot pro. That becomes a place for my website that I will push to my own platform when I push. But before I push, I need to have a platform that I create, and we'll do that soon. But right now, what Heroku has done is given us this, which is they have a wildcard DNS like this, and they use that wildcard DNS to generate random names like this, and we use that, and we will use that right now. So we'll go back here and look at our terminal where we have a remote that matches what Heroku placeholder is, but in that location there is nothing. It is empty. It just created a placeholder for us. So we need to now send our stuff. How do you send our stuff? You push. That's it. And we are done, by the way, after that. So a push is as simple as git push Heroku master. And this idea is to git push the whole thing to a name of the remote is Heroku. Send them the master branch. That's what we intend to do. So here we go, git push Heroku master, and off it goes. It is sending the whole Git repository over to Heroku, which it did through a git push, and then it is building bundle update, bundle install, match the Ruby version. Here we have our Ruby version matching 231. It is using bundler to install all the dependencies on that remote computer in Heroku, installing this, installing that, going on with all the things that we expect it to have, and then it runs the Rails asset pipeline, basically converts your static assets, your static elements in your website, and your JavaScript that you have converts CoffeeScript into JavaScript, converts SCSS into CSS, and then tells you that it successfully deployed. And here, verifying the deploy, done. Now you go to this link, and you should see the website. And so we want to see the website. We can say Heroku, open the website, please. So it opens up, and it will open up in the browser, and you should see the time right now. And the link is right there. So I paste it in Slack chat. And you can click that link and see the time in your location. That's our application. When we created that, we put that in a Git repository, send it to a platform, and it shows, and it runs. And it is running on a DNS name that they have given us. The DNS name looks like this, line number 5. It is basically a wildcard DNS under this name. And we have to create our own using something like this. or you can have, like I will be using an example that will be similar to line number 10, but my case will be slightly different, and I will be using this name. And that's what we will be doing next time. So does this thing open for you? Does this thing show you the time, the local time in your computer?
Yep.
Good, nice. So we did that exercise. There are these steps are kind of longish. It looks big, but it's not big. It opens nicely. It is a simple exercise, by the way, and you can do more things like database if you have, and so the steps are prescribed. Is how to do it if you have a database, and how do you migrate the database, how do you send data, and all those things. How do you further refine? There are lots of steps you can keep going and keep doing. I skipped some of it, but we necessarily don't want to focus too much on Heroku. Heroku exercise was more of giving you a flavor of what a platform as a service does. We will focus our energy on to building our own platform. That's what our primary idea is. So there are steps here to check logs and check this and check that. But you can follow through these steps. They will work for you. You will understand it better if you do it. And there are other steps here. Like for example, if you want to run your app in production mode, you have to spend money. And so if you decide to spend money, you have to give them a credit card. And if you do give, this is not necessary, by the way, don't have to. If you give a credit card, they will let you make a production app server in place. And so then you can use this unicorn production app server. So it becomes a professionally hosted site. But this is, again, not necessary. You can do it. If you like to spend money, it will not actually cost you. They just require a credit card. It is still going to be free. But credit card may not be desired, so don't do that if you don't want to. Next, and I think that mostly concludes this exercise. There are more steps here for production mode deployments, which I am not covering, but I would like to now briefly discuss as to what do we do next. So what I want to be able to do is the idea that next time, which is this exercise, is daunting. It is big. I must caution you. It might look like one page here, but it will take a lot of time, a lot of understanding of things that go along in building stuff. Excuse me. It will become easy if you finish the Heroku exercise. This particular exercise will become somewhat easy to understand, to implement. But if you just read this exercise, it's just one page, all of it. It can be really, really challenging, especially the DNS parts and the wildcard DNS that I mentioned here. Those aspects can be tricky, and we will go through that. Don't worry. I will have the whole exercise complete, and then we will have our own platform running in SunCloud. And our idea would be to use this software. It is available here in GitHub. This piece of software is available. You can see that it has a bunch of versions available, 1.3, 1.13.4, and all that. But I think I want to stick to this version, 1.13.3. That's what I want to stick to because I have tested it. I think the other version will also work, but I haven't tested it. So just we'll stick to the version that we have tested, and we might decide to change it. We'll see. And that's our plan for Monday. Is it Monday? Monday is what? First. Yeah. So
Mayday.
Is it a holiday on our calendar or what? I'm just checking.
No, it's not.
Okay.
Just the 1st of May.
Yeah, May Day is a holiday in India. That's how I get confused.
Oh.
Yeah, May Day is considered Labor Day, and it's a holiday in India. That's the reason for my confusion. But so 28th, and then the next date is May 1st. I just want to confirm that before I confuse anybody, because I got confused. So the dates are May 1 and May 3. So 2 days left for the cloud technology segment. We will see all of you again on May 1st at 4 o'clock Pacific time, 7 o'clock Eastern time, 6 o'clock the other time. I don't remember the time zone for your location, John. It's called Central or what? Is it?
Yes, it's Central.
Okay. Central time. So Central time, 6 o'clock, Pacific time, 4 o'clock, and East Coast time, 7 o'clock. That's what we'll see you guys again. And I will now stop recording and ask questions. If you have questions, please bring them.